Hello, today we are going to explore how Powertools for AWS Lambda can ease and simplify the creation of AI agents on AWS. An agent is an autonomous software system that leverages AI to reason, plan, and complete tasks for humans and/or other systems. Amazon Bedrock Agents are a fully managed service that helps you build agents backed by foundation model-powered orchestration. We will create a conversational agent that can invoke an AWS Lambda function to perform various tasks for your users. And we'll show you how Powertools for AWS Lambda can help you accomplish this. So what we're going to do to begin is we're going to have a look at an agent that I've pre-prepared here. We're going to inspect the properties of it. We're going to see how you wire it up to a Lambda function, and then we're going to have a look at the code that actually backs the Lambda function and how it integrates with Powertools. So let's click in here and let's have a look at the properties of the actual agent. So the first parameter here that you'll most likely be interested in is the model. So this is which foundation model you want to use and what you want the agent to process the prompts with. And so I've just used Claude 3 Haiku here. We then have the instructions that you can give to the agent. This is just sort of a high level description of what the agent can do. So for example, we can see here that it can do a couple of tasks. It can get the current time, it can greet users, or it can do some basic arithmetic. Now, that's all well and good, but we also want to describe what this agent can do more formally. So Bedrock Agents have this concept called action groups, and this is where you describe in detail what these tasks do, or what these functions do. You can see here now that we have this Lambda function here that processes the agent's prompts. And you can pick any Lambda function you want. We're using .NET today, so that's the Lambda function that I've decided to use. And what we have here now is the description of the actions and the functions that this agent can perform. So the first one here is get current time. This is very simple. It doesn't take any parameters. That's pretty self-explanatory what it does. And then the next function we have here, this greets the user. This does take a parameter, as a parameter called name, and that's obviously the name of the person that you want to greet. And then we have the simple calculator. This is a more complex tool or function, and you can see here that this one takes 3 parameters. And you can note here that 2 of these parameters are numbers, and then one of them is a string, which is operation, and that's actually whether you want to add, subtract, multiply, divide. And that's how the agent knows what it needs to do. Now, before you actually start anything, there's a small little gotcha that can trip you up. So before your agent can actually be used, you need to give the Lambda function, or you need to give Bedrock service permission to invoke this Lambda function. So you basically go into the permissions and you need to add a resource-based policy here. You'll see here what I've just done. I've made the principal, which is the Bedrock service, and then the Lambda function that we want to invoke. And then I've scoped down the source ARN of this resource policy to the actual ARN of the agent itself. So this is just standard principle of least privilege stuff that I always recommend you do whenever you create an IAM policy. Now, before we dive in and implement the Lambda function that the agent is going to use using Powertools, let's take a step back and let's try and implement this without using Powertools. This is going to allow us to compare and contrast the approaches and show you how Powertools can make your life easier. So let's just dive into the code here. So here we can see this is the vanilla Lambda function. There's a couple of very obvious functions here. We've got get current time, greet user, we've got simple calculator. You can see here that it takes 3 parameters, and if you note, these will match what we have in the action group here. Okay, so we can see here A, B, and operation, and the different types as well. And what we also see is that while we have these functions, we also need to have a bunch of logic to figure out which one to invoke. So here we're getting in the event that we get from the Bedrock service, and we're identifying the function that needs to be invoked, and we're identifying any parameters. Okay, and then what we do is we use a switch statement here to figure out, okay, well, if it's get current time, we need to invoke this method, and so on and so forth. And also know here that we've also taken care, because these come in the event, they come to us as strings, we also need to look after the parsing ourselves. Okay, and you can see here already that there's quite a lot going on here, and like as you add more and more functions for your agents, this is just going to grow and grow. So this is only 3, and we're already having to do a bunch of error handling here, make sure that we route to the right place. And that's before we even get to the response and making sure that the response is the right shape that the Bedrock service is expecting. So you look here, I've created a bunch of types that map to the type that Bedrock is expecting, and I have to ensure here that the response type matches exactly what the Bedrock service is expecting, or else it will just fail. So you can see this is just a lot of boilerplate, a lot of housekeeping. And I mean, when we think about it, ultimately, this is really all we care about. This is the business logic that our users are going to use. This is what's going to deliver value to your customers. So we can do a lot better than this. And that's where Powertools comes in. So let's have a look at this Powertools implementation then. As you can see here, some familiar code. This is the business logic. This is not going to change from the previous version. But this is the thing to take note of, this Bedrock agent function resolver. So this is the key abstraction, which is going to allow us to make a much more concise Lambda. It's going to help us remove a ton of boilerplate here, okay? So what happens is in the constructor here, you just instantiate an instance of this resolver class here. And what this does is it gives you a fluent interface that allows you to register methods that correspond to the various functions that your agent wants to accomplish. So you'll notice these guys here: get current time, greet user, simple calculator. These all map back to the agent group that we had in the agent in the console when we were looking earlier, and they just map it again back to these particular methods. But now look here at our function handler. Look at how simple this has got. There's no if else statements or switch statements to try and figure out what function that we need to invoke. There's no casting anymore. This is again all taken under the hood by this resolve method. We don't have to worry about returning the data in the right shape. Again, the resolve function just makes sure that the function of this gets wrapped in the data structure that it's meant to be, and it just sends it on to the agent. So before we start tinkering with the code though, let's actually just have a look at this agent that's running this code, and let's just sort of test it out a little bit, okay? So first of all, let's just try the simplest action that we have here. So let's go, what time is it? Click on that. And this is fine. And then let's try our multiplication use case. So multiply 345 by 768 and run it. Now, this is all well and good when the operation succeeds. But of course, as we know, things can fail all the time. So let's have a look at how this use case will be handled. Okay, so what we're going to do is we're going to artificially induce an error here. And the great thing about this resolver abstraction, this tool method here, is what it does is it wraps the invocation of this function in a try catch, and then it makes sure to return a well-formatted error to the LLM so that it can know what to do next. So I'm just going to create just like an exception here that says like cannot get time or something. Cannot get time. And then what we'll do is we'll deploy this change. So I'm just using Sam here because it just makes it easier for me to build and deploy the tool in a very simple single commands in the CLI. I don't want to be zipping up things and going into the console to upload. So anytime we make a change, we're going to have to do this. We're going to have to build it and we're going to have to deploy it, because you can't edit .NET code in the Lambda console like you can with Node.js and Python. So let's deploy this, and then once this is deployed, what we will do is we'll go back into the agent console, and we will try and invoke the function that errors here. So just creating the change to that. Okay, yes. Now it's updating. And yes, this is just updating the Lambda function now. And once we've done this, we'll be good to go. Excellent. Okay, so this is done now. Let's go in here. Let's clear down this session and let's go. What time is it? And now, here we go. I encountered an error when trying to get the current time, so I'm unable to do it. So the LLM knows what to do. Now, there are cases when you might want to have more granular control over the error that you return. And to do this, what we're going to do is we're going to update our Lambda function here, and we're going to actually return, we're going to make use of this class here, this Bedrock function response class. Okay, so what this class does is this actually ensures that the shape is correct. So this is actually the shape that's expected. Okay, and something that you want to know here is that you can set this response state variable. So what this does is this gives a very hard failure. If you use failure, the LNM will end the conversation. And sometimes some errors are so catastrophic, that's what you want to do. If you note now that the return type of the function has changed, so we're sort of using the raw response rather than allowing tool, because under the hood, all tool does is it wraps your response. It wraps the result of your function in this response. But sometimes you want to drop down to that lower level so that you've got control over this. Okay, so let's build this and then deploy it. And what we'll do is we'll try now and invoke the greet user function. And when we try to do that, it's going to fail, and the conversation will not be able to continue. And this is an enum. There's also a thing called reprompt. So you can do response state.reprompt, and reprompt will actually try and continue on the conversation. So it will like ask you maybe to clarify something, or say, look, I can't do this for you, but I can do something else. Okay, so it doesn't end the conversation. So that is nowhere near as final as this. So this is nearly uploaded. Yeah, cool. All right, so let's clear the session. All right, so now let's just say greet user John Doe. Okay, maybe we're on here. Now, you see, so the function failed, and that's now the conversation is over. So there are other times when you might want to drop down to this Bedrock function response level. And one of those is when you're making use of what Bedrock terms session attributes. There's sort of a way of persisting state across prompts. So what we'll do is we'll overwrite this implementation of greet user again to show you how to persist these session attributes. First thing you'll notice here is that we've changed the type signature. We've now added this optional Bedrock function request. So this is the raw event type that we get back from the Bedrock service. And you'll see on this request object, there is a field called session attributes. So for example, there could be multiple functions that are chained in a conversation, and you want to persist these session attributes across each prompt. So what you'll normally do is you'll create a new dictionary out of the existing session attributes and then just append the metadata that you want to add for your particular tool. And then once you've done that and you're happy with that, then when you construct this Bedrock function response, you set the session attributes field to this newly updated dictionary. But that's not just where the usefulness of this request object ends. You can also add another optional parameter, which is the Lambda context. And you'll see here that, for example, say we wanted to do some extra logging here. So we might want to log the agent ID. So the agent ID lives on the request. So we will do console.write line. And then what we can do here is request.agent.id. And then we might also want to then want to get, say, the actual request ID, the AWS request ID from the Lambda function, and that lives in the context object. Context.AWS ID. And there you see. So any of your tools that you create, you can add these in addition to the parse parameters, and it's just a nice, useful escape hatch if you need to go down yet again to a lower level, or even just to get some more identifying information. So there's plenty of other features that I haven't had the chance or time to go into here. The documentation on the Powertools website is very thorough, and there's lots more information on there, so I recommend checking that out. So thank you for listening, and happy building.